Welcome to Daily Papers, the podcast where we break down the latest and most interesting research papers into bite-sized, easy-to-understand chats.
Today, we're diving into the world of AI and photo editing. If you've ever used portrait mode on your phone or tried to remove the background from a picture to make a meme, you've used the kind of technology we're talking about today.
Exactly. That magic of perfectly selecting a person or an object in a photo is called image segmentation. And a little while ago, a groundbreaking AI model was released called the Segment Anything model, or SAM for short, and it was a game changer.
A total game changer. You could give it any photo, click on an object, and bam, it would draw an outline around it. A dog, a car, a lamppost, a single grape in a fruit ball. It could segment, well, anything.
But there was a small catch. While Sam was amazing at identifying objects, its outlines were sometimes a little rough, a bit like cutting something out of a magazine with chunky scissors. You get the general shape, but the fine details get lost.
Right. For a quick edit, it's fine, but for professional applications, you need more precision. You need to capture every single strand of hair, the fuzz on a sweater, or the delicate wisps of a cloud. Those chunky scissors just won't do.
And that's where this new paper comes in. It's called Segment and Mat Anything in a Unified Model, and it introduces a new model called Sama.
Sama, so it's like Sam's more refined artistic sibling. To understand what Sama does, we need to quickly define two key terms, segmentation and matting.
We've already touched on segmentation. That's the process of drawing a hard line around an object. A pixel is either in the object or out of the object. It's a binary yes or no decision.
But matting is the next level. Image matting is all about handling the tricky semi-transparent edges. Instead of a simple yes or no, it asks how much is this pixel part of the object.
Think about a person's hair against a blue sky. Some pixels are 100% hair, some are 100% sky, but many pixels along the edge are a mix of both. Matting figures out that a pixel might be, say, 30% hair and 70% sky. This information is stored in what's called an alpha mat.
The alpha mat is basically a super detailed grayscale stencil. White means 100% part of the object, black means 100% part of the background, and all the shades of gray in between represent different levels of transparency. It's what lets you create those seamless cutouts where the hair looks natural and not like a clunky helmet.
So historically, segmentation and matting were two separate tasks, often done by two separate AI models. You'd first segment the object to get a rough idea, and then use a matting tool to refine the edges.
But the authors of this paper realized there's a strong connection between the two. Segmentation gives you the big picture context of what the object is, and matting provides the fine-grained local details of its boundary. So they asked, why not do both at the same time in one single model?
And that's Sama. It's not a completely new model built from scratch. Instead, it's a clever, lightweight extension built on top of the original SAM.
Think of it less like buying a whole new car and more like adding a high-performance upgrade package to your existing one.
And I mean lightweight. The new components that Sama adds only increase the original model's size by 1.8%. It's incredibly efficient.
So how does it achieve this new level of precision? The secret sauce is a technique they call a multi-view approach.
It sounds complex, but the idea is actually intuitive. When Sama looks at an image, it doesn't just look at the whole picture once. First, it takes in the entire image to get the general context. That's the global view.
But then it does something clever. It also crops the image into 4 overlapping sections and looks at each of these sections up close and high resolution. These are the local views.
It's like an artist who squints to see the overall composition, but then pulls out a magnifying glass to work on the really intricate details.
Exactly. These close-up local views allow the AI to see things the big picture view might miss. The texture of a chair's weaker mesh, the thin bars of a metal gate, or the individual whiskers on a cat.
Then another special component called a localization adapter takes the broad understanding from the global view and intelligently combines it with the rich detail from those magnified local views.
The result is a single unified process that produces two outputs simultaneously, a super precise segmentation outline line and a beautifully detailed alpha matte for handling all those fuzzy, transparent edges.
Okay, so the theory is great, but did it actually work?
Oh, it worked spectacularly. The paper is filled with examples that show the night and day difference. In one image of a complex, weaker chair, the original SAM just produces a solid blob, but Sama's result perfectly captures all the tiny holes in the mesh.
I saw another one with a woman wearing glasses. Other models struggled with the transparency, but Sama's output clearly shows the frame, the transparent lenses, and even the fine strands of her hair blowing across them. It's a huge leap in quality.
And it's consistently outperformed the original SAM and other competing models in benchmark tests for both segmentation and mounting. It's more accurate, more detailed, and it's doing two jobs at once.
So what does this mean for the rest of us? Why does a more precise AI cutout tool matter?
Well, on a basic level, it means better creative tools for everyone. Your phone's portrait mode will get better. The virtual background on your video calls will stop glitching around your head. Creating high-quality product images for online stores will become much easier.
But it goes beyond that. This level of precision is critical for professional visual effects. Think of creating seamless green screen effects, but without needing an actual green screen. You can just film anywhere and have Sama perfectly cut out the actors.
And in fields like medical imaging, being able to perfectly segment a tumor or an organ from a scan is incredibly important. In autonomous driving, precisely identifying the boundaries of a pedestrian or another car is a matter of safety. Higher precision is always better.
So, to sum it all up, the researchers took the brilliant but slightly clumsy segment anything model and gave it a precision upgrade.
They did it by cleverly combining two tasks, segmentation and matting, into one unified model called Sama. By using a multi-view approach that looks at the big picture and the tiny details, Sama can produce incredibly accurate and detailed cutouts of any object.
It's a fantastic example of how AI research builds on itself, taking a great idea and refining it to push the boundaries of what's possible.
And it means the next time you blur the background on your selfie, the result will look just that little bit more perfect.